Hello everyone. Thank you, Dr. Wan, for the introduction. You can scan the QR code to access my slides. I also send the link in the chat. So for today, I'm going to introduce the Python package I created recently called GeoAI. And so here is the outline. I'm going to show you some of the critical features that you can use the package to do deep learning with your geospatial data. And I also have a GitHub organization called Open Geospatial Solutions that hosts many of my packages, data catalog, and web apps. So for today, we're just going to cover GeoAI. But if you're interested in learning other packages, welcome to check out the GitHub organization. It's open access, so you can also contribute your package if you want to. But I'm going to focus on the GeoAI package. So it's an open source package that for integrating AI with your geospatial data. So you can do geospatial data analysis, you can do visualization. It's still pretty new. I started working on this one, I think, just a month or two ago, and it has already gained a lot of traction. So again, it's open source. I will welcome your contribution. I'm not an expert in AI, but I'm just starting working on that, and so trying to make it easier for people to use AI with geospatial data. And so it's a Python package. You can install it using the traditional pip or conda or UV. And it also support GPU. So if you have GPU access. Next, I'm going to quickly go through some of the key features, what kind of things you can do. And so the idea is to make it easier. So all the features they're going to show you, probably you might have used it, you might have developed by yourself or use other desktop GS or other packages. But I can guarantee you it's going to make it so much easier. Many of the things pretty much is just one line of code, or even you don't need to write code in the future once we integrate the interface. So the first one is how to download the data. So in order to do AI, you will need a lot of training data. If you already have training data, great. But if you don't, there are some alternative there. You can get some data. So I recommend Microsoft Planet Computer and also Over2 Maps. So Planet Computer has a lot of geospatial data, satellite imagery, land cover, anything like that. They have, I think, 20, 30 petabytes of data. So it's all open access. You can download the data for free. If you use GeoAI or LeafMap, you can just pretty much download the data using just one line of code. Specify the bounding box that you are interested in, and then specify the data that you want, and everything else is automatic. So just two lines of code, you can get the data that you want. So for example, later, if you want to train a model to do building detection, you will need satellite imagery. You will also need some building data. If you don't have anything, this is perfect for you. So just a couple lines of code, you can download data for any location around the globe, as long as they have the data for that. So for all the key features I'm going to show you, there's a link to the notebook. So everything that I'm presenting here today is reproducible. So everything will be, you can run it yourself, you get the same result. So, all you need is just follow the example, how to set it up, and then you should be good to go. So Planet Computer, as I said, you're welcome to check out the link. They have tons of data. It's kind of a alternative to Google Search Engine, but this is all open access, so you can download a large amount of data through Planet Computer using just one line of code. Also Over2 Maps. So this is a new open access data initiative led by some of the big techs, AWS, Meta, Microsoft, and TomTom. And they provide data, for example, building, roads, and places, POI, so a lot of data. Petabyte of data, not petabyte, like at least thousands of gigabyte or many terabyte, and it's all open access, so it's free. You can download the entire data set at the global scale, just a couple lines of code. Again, you can use GeoAI, so you can see the snippets here. Just import the library, specify the bounding box, and then you can download building data, roads data, whatever you need. So those data are great training data for training deep learning algorithms. Pretty high quality because it had been fact-checked by those companies. And so once you have the data, you might want to visualize the data. So GeoAI built on top of LeafMap, so you can utilize a lot of LeafMap features, allow you, for example, to source data interactively. So all you need is just zoom to anywhere around the globe. You don't need to write any line of code. Then you can just select the data that you want. It can be DM, it can be satellite data, it can be land cover, any data you want, and then you can at least visualize the data interactively without having to download the data. So you can source data from Planet Computer, from AWS, from any third-party data catalog. So this data can be gigabyte, but you don't have to download anything. You can see the data first, and then make sure the data is the one you want. Then you can download the data. You can also visualize data on 3D globe. And yes, there's a question about global scale. Yes, so It depends on the data catalog. If there's global scale, it's global scale. So you can zoom to anywhere that you like, and then you can download the data. You don't need to download data, visualize the data, and then you can download the data. You can visualize in 2D, visualize in 3D. So this one demo here shows you the 3D globe building data from Overture. So the data set is like 200 gigabyte. You can just visualize it directly without having to download anything, and it's instant. It's free, and just 2 lines of code, you can create fancy 3D maps easily using leaf map and also GeoAI. Again, there's a link to the notebook, so welcome to try those out. You can also create vector data. So for doing deep learning, sometimes you will need to have training data. You can use desktop GIS to create training data, but you can also use the package to directly create training data. So you can do it just within the web interface. And so everything that I'm showing here can be run using a browser in Google Colab or any other cloud computing environment. You don't really need to set things up on your computer if you don't want to. So you can create training data, you can assign attributes, anything that you like. You can also edit existing vector data. So assume that you might have some training data from other sources, but they may not be super accurate. You can load the data, 1 line of code, and then you can start editing the vector data, and then you can move the location vertices or something like that. Again, you can check out the code snippet here to see how to do that easily. So basically allow you to prepare training data using the package. So once you have the data, now you need to start preparing the data, creating image chips. Because for doing deep learning, unlike in traditional remote sensing, you can feed the entire imagery and then just start doing the data processing. In deep learning, they are pretty much function they operate on image chips. So you need to create image pairs. And so in the package allows you to do that just 1 line of code. So assume I'm trying to do building detection. I have a satellite imagery or area imagery, and I also have the building. It can be vector data, or it can be just the building mass. And then with this, we can create image chips. So what it looks like is going to basically do the sliding window from the left to the right, from the top to the bottom, and then you can create image chips like this. And then you can feed all the image chips into the deep learning model. So this can be done just 1 line of code. Just provide, okay, where's your imagery located, and also where's your vector data, polygon, or whatever, and then 1 line of code to create image chips. Of course, you can use any other open source alternative, but you have to worry about the projection and then the conversion, the raster resolution. There's so many things to worry about. So using the package, just 1 line of code, and then you can just use the default settings. It should work out of the box. So once you have the image chips, then you can start doing the model training. And again, just 1 line of code, you can train a Martian model, you can train a UNet or anything. Everything is just 1 line of code. So you see on the left side here, I have the image chips, and then I start training the model pointing to the imagery and also the label. And you can specify how many channels. So it can be multispectral, it can be hyperspectral, it can be any number of spectral bands you're going to pre-train, and then just use the default settings. You'll be able to actually get pretty decent result. And once you train the model, then you can start running the inference. So basically, you can apply your model to do segmentation, for example, on a new imagery. And again, just 1 line of code. Just call the object detection, and then just passing the imagery that you want to classify, and that's it. Then you will be able to get the result. And so we can, after you get the result, we can also do some post-processing. So for buildings, you might want to, for example, rectangularize the buildings. So the package also has function that allows you to do that, to rectangularize. There are a couple other alternatives out there in desktop GIS, but they are not open source. And actually, this one is actually quite a challenging issue. So there's not a perfect solution open source that I have found that works well in all cases. If you are aware of any of those, I'm happy to learn and integrate into the package. But for now, I have some load functions that can help you do the post-processing pretty easily just using 1 line of code. So you can get building nicely. You can use other structures, rectangularize the outline, and then make it look better. So for example, here I show you some of the buildings. For example, this can be buildings that you get from the output from the deep learning. And so after you do the rectangularize, it looks so much better. You can also compare with your there are multiple algorithms available in the package, so you can see which one works best. Sometimes you might need to use a combination of those. Again, all those, there's a notebook link there. You're welcome to try it out. You can also calculate the geometry properties. So after you convert the raster mask to vector, sometimes you might have some false positive. For example, you might have many smaller objects that are not supposed to, for example, to building. Then you can calculate the geometry properties. It will give you, as you can see here, size, the length, perimeter, bounding boxes, and also some of the geometry properties. So you can use those to filter out those false positive objects from your results. Again, just 1 line of code, you can calculate the vector data or geodata frame, then you can just based on those to do filtering. So those are some of the key features, kind of basically the workflow from downloading the data, visualizing the data, and then training the model, running the inference, and then calculate geometry. So basically, the whole workflow is pretty much just 5 lines of code, and it's very flexible. It's very generic, so you can apply to many applications. Because a lot of people are not really experts in coding. They don't really know how to construct a deep learning model. So this is a perfect use case for those that want to get started but not really an expert. The process is so much easier now with the package. So next, I'm quickly go through some of the applications to show you some of the power. So you can certainly do building detection. So all we need is imagery and also vector building footprints, for example, or it can be raster, and then two imagery. And you can point to the pre-trained building detection model, or you can train your own model. So as you can see, all we need basically is just four lines of code. Then you get the result. So very easy to use. You can also do, for example, solar panel detection. So if you have the data, you have some good training data. If you're working on some of these like energy sector, you want to detect how many solar panels, you can do it easy. Again, 4 lines of code, you can get the polygon nicely exported from the algorithm. You can do car detection. So if you someone want to check the traffic flow to a shopping mall or something like that, you can also easily do that. Just train your own model and then you can apply it to do detection. You can do ship detection. So you want to see the flow of those ships docking in the port. You can also do that easily. So the ship detection and also surface water. So if you want to map surface water, so for example, this one shows you using the USDA NAP imagery, so 60 centimeter resolution to map surface water. So again, 4 lines of code. You can train your own model, or you can just use the pre-trained model from the example. By the way, so these are just examples, just demos. It's not going to be super accurate. If you zoom in, you want to see some issues, but the idea is that we make the process so much easier. And if you have good training data, you can train your own model. It's going to be so much better than just using the pre-trained model. Also, you can do wetland mapping. So, for example, I use the National Wetlands Inventory here in the US, and those data are just delineated in the 1980s. They have not been updated for decades. So I can just use those not so good training data. I train the model. I can delineate the wetlands pretty nicely. Again, not perfect, but it's going to save you a lot of time if you're trying to do this manually, because in the 1980s, 1990s, they just did the manual digitization. But now with this new AI and also updated area imaging, we can automate the process to create and update the inventory with this kind of techniques. You can also do lane cover classification. So if you have multi-class and you want to focus on like classifying the lane cover of the imagery, you can do that as well. It's the same process. So for this one, just 1 line of code and then semantic segmentation. Give it the imagery and then also your lane cover classification, and then train the model, and then 1 line of code just to apply that to a new area. Again, there's a notebook there. You can try it out yourself. So these are some of the key features. Next, I'm quickly give you some additional features. These are the one that I just added 2 to 3 days ago, so it's still pretty new. And again, it makes it even easier. So in the early example, I show you how to create the image chips from 2 data sets, right? 1 imagery and also 1 vector, for example, building footprint. But if you want to train a model that's robust enough that can handle a lot of cases, you might have training data from everywhere. For example, if you're doing this, say, lane cover, you want to create image chips, but you cannot just create image chips, for example, for Knoxville, and then expect it to be applicable to the entire US. It's not going to work. So you need to have image from multiple locations. You also have the corresponding lane cover from multiple locations. So now the package allows you to do that. So all you need to specify of pointing to the folder of images and also pointing to a folder of lane cover or any mask or whatever you like. So just pointing to the data, and then you create the image chips automatically. So basically, it allows you to create image chips from multiple images, not just one. Okay, so you can have 2 folders of data, and then you can create image chips. Then 1 line of code, you will be able to apply, train your deep learning models. And you can also train the model on non-geospatial data, because not all the data comes in the GOT format, and also in a lot of competition in the computer vision discipline, a lot of data actually is just JPEG and PNG, so they don't have geospatial data. So basically, have the images and have the corresponding image chips in JPEG and PNG format. Now the package also support that. So again, you can just call the function one at a call pointing, and then specify the input images, the folder to the input images, and also the folder containing the mask, and that's it. So it supports both geospatial and non-geospatial data format. So the example they show here, I apply this one to the surface water dataset that contains thousands of image chips and also the water mass, and then can train the model and then can apply that to do water detection using satellite imagery. Also, you can do batch segmentation. So you can create image chips for multiple images, or you can also apply segmentation to a bunch of images. So imagine that you have a lot of images that you want to classify. So in the previous example, you need to do that one by one. So once you train the model, you can only apply the model to one imagery. But I just added the batch segmentation 2 days ago. So now you can just call the segmentation batch and then just pointing to the directory that contains all the images, then you will generate the result for all the images. So very, very easy to do. Also, you can combine multiple sources to do detection. Segmentation, for example, I can combine area imagery and also LiDAR data. In this case, it's the height above ground data to do building detection. So you can combine multi-sources. For example, let's say you might want to do maybe vegetation or water, whatever, right? You can use the original multispectral data, but you might want to add, for example, NDVI band, NDWI band, LiDAR band, or whatever, or SAR. You can combine all them together as a single imagery. So in the package has one function allows you to just input a bunch of images, and then you will combine them all together as a stack. And once you have the stack, then you can create image chips. So you're going to get the corresponding, basically you have two images stacks, and then you can just point into the data, and then the rest will be the same workflow. You can use it to detect, to train your model. So in this case, I use it to do building detection with high resolution area imagery and LiDAR data, and the results are much better than just using the single area imagery, because you want to get a lot of false positive, many objects on the ground that do not have height. So with the LiDAR height above ground data, you was able to actually remove many of those. And I think this is the last example. So you can also do train a segmentation model on satellite imagery with multispectral bands on satellite data. So many of the examples that I saw earlier focus on high resolution area imagery, but we also have tons of satellite data, for example, Sentinel-2, Landsat, or MODIS, or any other satellite data. You can easily use them just to train a model. So again, go to the notebook, one line of code, just provide whatever, pointing to whatever data that you have, and then also the label, the mask that you have, and then you will train the model, then you can apply the model to multiple images. So pretty much if you are focused right now doing like segmentation, you can use the package to get things done just with 4 to 5 lines of code, and you don't have to really worrying about how to construct your model architecture. If your goal is just to get some initial result, this can be a good time saver, but it's not going to be the most advanced algorithm. So I want to point it out here. If you're already an expert, this can help you reduce the time to do the data preparation and also train the data, but you might not necessarily get the base accuracy. So far, focus on segmentation, but there will be a lot more instant segmentation, change detection, and a lot more features coming. And I also welcome the contribution. If you know how to do coding, welcome to contribute. So lastly, I want to show you some additional resources. I have a YouTube channel that I post these tutorials regularly with almost 50,000 subscribers. So if you want to follow the latest update, check out the YouTube channel. And for specifically for GeoAI tutorials, I think so far I published 24. So you can check out the link to show you step by step how to get started, and also how to follow through if you prefer video tutorial. And also recently published a book, Introduction to GS Programming, not AI, but if you want to learn Python programming, this might be helpful. So you can check out the link how to get access to the PDF, and also you can buy the copy from Amazon. Also, this is a course, so you can also check out the tutorial. So this is a course that I taught at the university, but it's all open access, so you can check out the video without enrolling this course if you want to learn how to do programming. I also have another course teaching how to design Python packages. Again, open access. You can check out the link, and also the whole semester, all the courses are freely available online. And if you want to try out all the features that I showcased today, you can check out the link here to the workshop. Then there's notebook that show you many of the critical features of the package, so you can get access to all the key features in one single notebook. Okay, so that's all I want to say. Thank you very much for your attention.
All right.